मैंने चालू कर दिया रिकॉर्डिंग फ़ोन पे तो बस ताकि एको ना हो कि फ़ोन को बाहर रखा हुआ है अंदर। पूरी
लिंक भेज देगा तुम्हें ग्रुप पे।
हाँ, भेज दिया तुमको। मैं अलग से यूट्यूब पे ट्राई कर रहा हूँ, अलग से अलग सा। जयंत आई थिंक तेरे वो 2 डिवाइस।
एक से माइक से यूज कर रहा हूँ मैं, इसका माइक बहुत खराब है लैपटॉप का।
फिर कम लोग हैं तो फ़ोन लाइफ पे चालू रखते हैं।
think this makes sense. Does this make sense? No. Wait. Yes. Wait a second. Okay. Um. Wait. I think I need to rethink this a bit. Wait. I'm not so sure. I'll do LR reminders first. I'll comment that later. Go again. So here, I'll just explain it later. I think I miscalculated something. I don't know. So yes, this question is given key there are n elements. There's a positive integer m and string of command length n. Each command is either the character L or the character R. Process all n commands in the order they are written. Processing command is done as follows. First, output the remainder of the remainder output here. So I hope you have read this question. Just read the ones at the question. Okay, so I'll explain the question once. I'll just take this test case. 4, 6. So what is asked in here is that at at every step we are supposed to calculate the product of these elements and output P modulo M is what we are asked to do. And then what we have to do is we have to follow whatever this element says, right? Whatever these elements says, and remove if it was L, remove the leftmost element, and if it was right, remove the rightmost element, and recalculate the product for the next step. So the brute force method is very easy. Brute force तो नहीं मतलब normally method. So first you calculate all the product things by multiplying them all, right? And here a second, okay, 3 and 4, 12, 24, okay, 6, 4, 7. Yes. So 3142 was 24 initially, and 24 mod 6 was 0. So the first output should be 0. Then what you will do is you will remove 3 because it was a leftmost element and the first thing was L. So you will remove 3. 1, 4, 2 are the remaining elements. The product will become 8. Right? And if the product becomes 8, in the next step, 8 mod 6 would be 2. So you output 2. Then it's R command. So you will remove 2. Then product will be 1 into 4. So basically what you do is you take the previous product and you divide it by the removed element to get the new product. Like इसमें 3 was removed, 24 में से 3 was removed. So you got 8 as the new product. So you don't have to recalculate the product again in O of n. Right? So the simple approach would have been like this only कि 0 और 2 उसके बाद 4 किया तो 4 आ गया, and then you did with 6, then you got 1. 0 to 4 1 should be the I guess yes, L R R 0 to 4 1 should be the answer. Yes, this is the answer. Hmm. So the thing would be this, but इसमें the problem is कि uh, say initial array was, the worst case can be कि there are 1 elements and each element was how much? 1e4. Each element was 1e4. So the product can go how much? 1e4 into 1e4 into 1e4, which is like 1e4 की power 1e5, which is very large, right? So, which cannot you cannot store even in long. So to avoid this problem, what you can do is key you can start from the last element. Last element as in key you were doing these operations, right? Like say it was 3142. You removed 3 first, then you removed one. Sorry, then you removed. Sorry, then you removed 2, then you removed 4, and then you were supposed to remove L, right? So the last element you removed was 1. So what you'll do is you'll begin from the reverse. So initially the array was 1. So I'll see that the product was 1, and I'll output my answer for the last thing first. P mod M करके, right? Then what I'll do is I'll reverse the things, restore the right element which I removed, which was 4. I think 4, yeah. Yes, it was 4. So yes, 4, you will restore and you will update the product again. P is equals to P times 4. And here the thing is ki you can do modem. Whereas in the initial thing you can't do modem because you are supposed to divide the things. So you can't do modem because the answer will come wrong, of course. So yes. So what do you do is you start from reverse and you get your answers like so on and so on for the entire array. And yes, that's the idea basically. Key by the front thing doesn't work, but the reverse thing will work. Due to the modem, the range becomes 0 to m minus 1. So yes, it will fit in the integer. This was fairly easy. And the last question is strange game on matrix. Um, in this, yes, this question was also simple, I guess. There are rows, columns, each. Okay. Minimum I search that. Okay. Square script. Look at this column. This is okay. Okay. Must maximize the score. Also, there's a change many elements. So it replace the minimum number of ones with zeros. Okay. So इसमें this is also simple. What the question is saying is that there's a matrix given with n rows and m columns. It's a binary matrix, so there are a bunch of ones and zeros. So what they're telling is we have to calculate answer, which is what do you do is you first find the first one while traversing the column from up to down in each column. So like say we are doing it for the first column, we'll find this one, right? And what we'll do is you'll locate the first one. Like say initially there was zeros, the first one would be this thing, right? So you'll locate the first one and you will see the next minimum of k comma the remaining elements, which are n minus I plus 1, and you will count the number of ones and add it to your answer variable. So what you have to do is you have to replace minimum number of ones to this one. I guess I think this one. What's the operation? Capture. Okay, yes. Any number of ones, yes. So basically the operation is you replace any 1 to 0, right? And you have to maximize the answer for for the entire thing. So you have to convert minimum number of ones to zeros is the uh, problem. So what will I do is key first understand one thing. Key we are only concerned with column. So if I was doing the things for column one, it won't impact column two. So you can also treat it like a 1D question. Like I'm only solving for a 1D array, like 0 1 0 1, because this effect of this is not on this, right? So I can just do it for a 1D array. So like I'll take an example for such like 1D array. So it was this type of array. Also, the another thing is key. It wouldn't make sense to remove a one which is lower when the upper there is an one in upside. Why? Because I'm going anyways gonna choose always gonna choose this thing, right? This one first because you're supposed to find the first one and uh, take the window size as something like this, right? So we might erase one which was beneficial to us. We might or might not, but why do you want to make your loss, right? So you should not like erase a one such that कि उसके ऊपर भी एक one हो. Like in this, we can this was one, this was two. So you can not erase two before one. You can erase two only if you have erased one. So you can simply brute force this. You can say that I'm trying to erase ones up to one. Like these ones I'm trying to sorry. So so what I'll try is key I'll try to make this one my first one in this column. So what I'll say is I erased all the ones up to these things. Then you will say okay, I erased all my ones up to these things. And I calculate my remaining number of ones in the window. Right? इसमें the problem is key to count the number of ones in the remaining window. You'll take another k thing of n into k for each column. So there is also one n. So this will become O of n cube. And to optimize this, you can use prefix sums. To calculate the number of ones in the window, you can use prefix sums along the columns. So what is the prefix sum? Prefix sum is nothing but see this was my array. So इसका prefix sum क्या होगा? It will be like the first element will be a of 0. Second element will be a of 0 plus a of 1. Third element will be a of 0 plus a of 1 plus a of 2. Similarly, third will be ऐसा करते करते मतलब हाँ so इसका prefix sum would be 0 0 1 1 2 2. So why does this prefix getting a prefix sum help here? So prefix sum helps to get the sum of this window in O of 1 instead of O of n. How? What you can do is key. Huh. So if you want the number of ones say in this window, what you can do is key you can get the prefix of this and you can get the prefix of this and you can subtract the uh, first prefix sorry subtract this second prefix from the first prefix sorry till here only. So you can subtract the second prefix from the first prefix to get this window. There's a number of ones in this window, the sum of this window. So you'll get the number of ones in this window. So the time complexity becomes now for each row, you are just sorry for each column, you are just trying to traverse every element in the column. So O of n into one for uh, for doing the for calculating the number of ones in the window into, it will be m for number of columns. So this reduces down to O of nm instead of O of nmk. So this will get accepted because this is I think 1000 and NNMR. Yes, that was it, and I'll once see the Trinity question and explain it afterwards. आगे किसका है आ जाओ.
हाँ मेरा है बट शेयर अपनी हटा एक मिनट स्टॉप शेयरिंग हाँ ठीक है so I'll be discussing first the question longest strike um, please read the question if you haven't. I'll give you some time. Yeah, so we are given basically we are given an array of length n and we have given an integer k. um, we have to choose such an L and R for every element between and including both L and R. The frequency of all the elements should at least be k. And if there are no such L and R satisfying the condition, we just need to output -1. So to simplify this problem, we can observe that the elements whose frequency is less than k, we don't need them basically. We can just uh, remove them from that array. So first of all, what we'll do is just take the array and make its frequency map. And for making the map, make sure to use the ordered map. If you use an unordered map, you will probably fail and you get a TLE on some test case 2022 something or that like that. So use an ordered map to make the frequency, and we'll just ignore the elements whose frequency is less than k. So we'll just make a new array and we'll add all the elements whose frequency is greater than or equals to k. Um, like for this example, k is equals to 2. Uh, we can see that 12 does not have a frequency greater than equal to 2. So we'll just make of array of 11, 13, and 14. We don't need to maintain the frequency as in such because we just need to return LNR. Now we'll just sort this array, like here in this case it is already sorted, but if it's not, we'll just sort this array and we'll just initialize our two pointer. Let's say I equals to 0 and j, we'll just do j equals to 1. And if like I can show you a pseudo code also, right? I have made a pseudo code. Yeah, so we'll just initialize the maximum length as equals to 0 and we'll initialize the left pointer as 0. Right now we initialize the answer index as -1 because we don't know if it's actually there or not. So we'll iterate toward the right pointer from 0 to length of L2 -1. um, and we'll check if the L2 right element, if it's not equals to L2 right -1 plus 1, which is basically like if 11 was my left pointer, the next element has to be 12. So this basically checks that if this is equals to this plus 1 or not, because if it's not, we have to just break it and we'll set is left as equals to right. And this condition basically increments my max length and keeps my answer index, basically stores the left pointer of the answer basically. So we'll just set the answer to the left pointer because that's the subarray we'll start from. So if the maximum length is 0, we'll just output -1 because there won't be a we can't have a answer in that case. Else we'll just set the start is equals to an answer index because that was the index I found my left, and n would be just answer index plus max length because we calculated the max length, minus 1 because we have to one based indexing thing, and we'll just output start and end. um, Let me know if you understood this, if any doubts. Okay, I guess there is no doubts, so I'll move ahead. uh, Next question I'll take is subtract operation. You can read the question, I'll give you some time. Yeah, so in this question, we are given a list of n integers. You can choose any integer from the list, erase that element from the list, and subtract that value of x from all the elements. So, like for example, we choose 4, 2, 2, 7. If we choose 2, that element is deleted, and we have to subtract 2 from all the elements. So we now get an array of 2, 0, and 5. Yeah. So in one operation, obviously the length of the list is decreased by exactly 1. We have been also given an integer k. We have to find if there is a sequence of n minus 1 operation. After applying the operation, there should be the remaining element of the list should be exactly equals to k. So obviously we can try this, but there is an observation here. So when you subtract an element from, like say when we say a2, a3, let's say we remove a2, uh, we get minus a2 minus a2. Let the now the element should be a1 minus a2 and a3 minus a2. Now let's say we subtract this from this, so we'll get minus a1 plus a2. So that is just equals to a3 minus a1, right? We saw that a2 got cancelled. So when you apply this on n elements, you will see that all the elements would get cancelled, and the answer would just be the difference between any two elements, between any the last two elements which were left in the which you did not choose basically. So every the k can be equals to all the options which are this difference of any two elements in the array. So like for this case 4227, k can be equals to difference of any two elements. Like we can get k between 4. If you subtract 4 and 2, you get 2, 2 minus 2 2 0, and 7 minus 2 5, everything like that. So in this question we'll just have to we just take the array, and we if there is only one element and that is equals to k, assume a is just k here. So if a is equals to k, we just return the answer is true, that we can which like answer is here yes, so we'll just return yes. Else we'll need to sort the array. We can see that sorting the array does not make any difference. um, we are just sorting the array here because we need to use the two pointer to get all the possible differences between elements. So we'll initialize our pointers 0 and 1, and we'll check j minus j and this is just two pointer connection, that they are not going out of bounds. And we'll check vi, we are assuming vi to be less than uh, v of j. So we'll just check vi plus a k is equals to vj. If it's true, then we'll set our answer to true and we'll just break out of it. Else we'll if vi plus k is less than v of j, then we'll need to increment I, because vj is currently more. Or if the other way is true, then we'll need to increment j, because we right now this thing is more, so we need to increase that. So if answer is true, we'll output yes, else we'll output no. um, did you under did you guys understand this? Any doubts? Okay, I assume everything's clear, so I'll move to the next question. This is a hard question. You can read this. Not so hard as in such, but yeah, I think is nice set. Okay, so in the question we are given that we Polycarp works at an ATM, and the ATM would contain S rubles initially, right? S is provided in the input. There are a queue of n students lined up to him, and each student will either withdraw the money or deposit the money. So if the AI is positive, then student would credit that amount. Otherwise, student will withdraw that amount. So in the beginning, ATM is turned off, and arbitrary number of students are not served. Basically, we can choose to turn on the ATM at any point of the time. And when you turn on the ATM, it will initially have S rubles. Then the students would start queuing up, and if at any point there is less money than the student wants to withdraw, then the student is not served and the ATM is turned off. Now you can't serve anyone, any more people. So it's also given in the question that the number of students will always be a contiguous subsequence. Basically, like if you have an array, you have to pick a continuous subsequence only. Like you can't pick an element from here and then an element of here, but you skip that element from here. So and have to pick a contiguous subsequence here. So Polycarp wants to serve the maximum number of students here, and you have to print the first and the last amount, or you determine if he will not be able to serve anyone also. So here the idea was to use prefix sum, like Meet also showed you how prefix sum work. So what prefix sum would give me that if I make a prefix sum on the array itself, like minus 16 to minus 6 and 8, what this shows me, the first student withdraws 16. And so if the ATM was currently active, we would have to need at least 16 rubles, right? So uh, the to get a sum of a subarray, we need to use prefix sum. It gives us sum of a subarray in O of 1, like he told you. So at any point, if a student is not served, what would happen is basically the sum of the prefix sum would go less than minus of the value of initial amount. Like because if the sum of the prefix is greater than minus of s, then we can obviously serve that amount of that prefix. Basically, we have to check that that prefix, can we serve it or not. So that is the question here. So we'll just create a prefix sum array, and we'll iterate over it. We have to serve the maximum length, and we'll set the start index and and index. This is basically the answer, and we'll start the start pointer at 0, and then we'll check for the end. End would start from 1, because here in my case I have initialized the prefix sum with n plus 1. So initially it has 0, and then it starts from there, so end has to be starting from 1. And will this thing would give me the sum of this prefix, which means this is the amount of rubles I need to serve that amount of people. If this is less than x, less than minus x, that mean I can't serve that amount of people, so I'll need to increment my start pointer. You guys understand this? We need to increment the start pointer because the condition is not satisfied here if it's less than minus x. You are guys understanding this? Okay, so next condition is just checking if start is less than end minus start is, if it's greater than the max length I had, so I'll just set the max length is equals to end minus start, and start index would be just start, and end is equal to n minus 1, because I had initialized the prefix sum as n plus 1, so I have to decrement it. So I'll just return start index, end index, and max length. If the start index is minus 1, that means I can't serve any prefix, so I'll output minus 1. Else I'll output the indexes, because I'll just increment 1 because they are 1 based indexes. Please tell me if you have any doubt. Okay, I guess that's it.
Hello, can you hear me?
Yes.
Yes. One sec. Okay, so let's start with problem F here, which is I think it's J in the contest. So yeah, I'll just give you some time to read this because this is like quite a difficult problem. So I'll just read it out once. So you have n enemies, each has a particular health and is at a particular position. You have a monster which has a stomp attack. So what it is basically is at some position X you can place the monster, and it will at position X at position P it will have a damage of P, and subsequently as you keep going farther, the damage will keep decreasing. So at position P it will be P, at position P plus 1 it will be P minus 1, and so on, M minus 1, sorry, and so on. So and you need to kill at least k enemies, and you need to find the minimum number of attacks which will kill k enemies, provided you can put it anywhere. So okay, there are it's not that difficult, it just has multiple smaller sub problems. So I'll just tell you what techniques this will use. So it will use prefix sums, binary search, and partial sums. These are the three main things which we are going to use here. So what happens is you have an array, something like this, and here the damage is m minus 1, m minus 2, m minus 3, so on. So okay, so when you put an enemy at P, so what you want to do is you want to kill at least k enemies. So let's simplify the problem a bit. Let's assume that you have only one attack and you want to kill k enemies or you want to kill as many enemies as you can using only one attack. So how will you solve this problem? Let's assume that let's take a sample test case here. Let's take this one. So 5, 5, 3, and let me just check NMK. Okay. So we are assuming that we have only one attack, and the monster deals a maximum 5 damage, and you have 5 troops you want to kill. So what would be the best thing to do here is you need to think in reverse. Basically, what you do is you think from the perspective of each troop. So let's say I want to kill this troop here. So what distance should the monster be from this troop so that it gets killed in one attack? Okay, so let's say this has health 7 here. So whatever this distance is 1 plus how far can the monster be here? It can be at R such that 5, 4, 3, 2, 1. This should get at least 1 damage, right? So 1 plus whatever damage you have, M, which is 5 in this case, minus 1. This is the right bound. And for the left bound, you do 1 minus M plus 1. I think, let me just confirm. So where you have 1 here. So you go 1, 2, 3, 4, 5. So 1 minus, and this index is, this is our distance 1, 0, minus 1, minus 2, minus 3. So it's 1 minus 5, which is minus 4 plus 1 minus 3, right? So basically this monster will get killed if you place, if this troop will get killed if you place the monster from minus 3 to 5. And for 2 also you'll get some particular LR range. For 3 also you'll get the range. So now you have calculated all these ranges for each element. Let's say this is in order, and I have whatever many elements. Now I just need to figure out where to place this monster to kill the maximum number of enemies, right? So let's assume I place a monster at P. So whatever segment, whatever this line, this vertical line, however many segments it intersects, that many monsters it will kill. So that now the question reduces to finding this point P such that you get the maximum number of enemies killed here. So how do you do that? So there is a thing called a partial sum. It is not nothing fancy. It's just a prefix sum, but it is just so one brute force method could be you could calculate the number of enemies it's killing in O of n for each of the troops. So O of n, to calculate the how many troops are killed, O of n again, because you need to do it n times. So total O of n square time it will take. So how can we optimize this? So what partial sum is it's a technique. So if you have L and R, let's say I have a very big array, enough so that it covers this entire minimum L and maximum R, right? So what you do is at L minus 1, you do minus 1, and at R, you do plus 1. Okay, so I'll explain why this happens here. So let's say you have these ranges 2, 3, let's say 5, 3, 7, 6, 9, and my array is 10, of size 10 basically. So at 1 I'll do minus 1, at 5 I'll do plus 1, at 3 at 2 I'll do minus 1, at 8 I'll do plus 1, at 5 I'll do minus 1, at 9 I'll do plus 1. And now if I take the prefix, what will happen here? Minus 1, minus 2, minus 2, minus 2, minus 2. Oh, sorry. My bad. So I messed up here. So it's +1 here and -1 at r +1 here. Right. Okay. So now see what happens when I take the prefix sum. So when I'm at 2, I'll kill one enemy. When I'm at 3, I'll kill two enemies. When I'm at 4, I'll kill two. 5 again 2. But then this goes away. But this comes back here. So 2, 1, 1, and 0 at so it's 10 here. Yeah, 0 at 10. So this is basically what you're doing is you're effectively calculating how many enemies you'll kill at a particular x in O of n. And why this is more efficient is because for the prefix sum, earlier you were doing the prefix sum for each enemy. Now you are doing it once for all the enemies. So, okay, so now you have calculated how many enemies you can kill. But okay, there's one more thing to note here. If you notice the x ranges, it's 10 raised to power 9. And you can't have an array of size 10 raised to power 9. So you can't use arrays to do the prefix. This thing that I just mentioned here. So what you can do is you can just put a map instead and have two numbers L and whatever this is, let's say X or whatever, and then uh, I can still do the same thing, right? So M of L minus minus M of L plus plus M of R plus 1 minus minus, and it is the same thing, but instead of uh, doing this intermediate things, you can just skip from the given segment. So instead of 4 here, you'll skip directly to 5. That's the only thing, and it's the logic is pretty much the same. So okay, now I know how to do it for one enemy for in one attack. Now what if, let's say I had X attacks. So there's a thing to note here is if I can kill k enemies in X attacks, I can for sure kill k enemies in X plus 1 attacks and X plus 2 attacks and so on. So I can say that this function is monotonic. Now, if it is monotonic, that means I can binary search on the number of attacks here. The only thing which will change here is the distance, because now if you see, we had initially taken only one attack, right? So in one attack you can do, if this monster's health was, let's say if this was 7 here, 7 health, if this was, let's say 10 also, then what will happen is 5, if I do two attacks here, I can still kill the monster, right? Even though my whatever the monster's maximum attack is, it is less than the given health. So you'll need to recalculate how you were doing, figure out how to calculate these L's and R's again. So what you do for that is pretty simple. So let's say you have a monster with 10 health. How many attacks will it, what will be the range effectively in which I can place the monster X times to kill it? So it is, what will this be? Can someone tell me? Do you have any ideas? Okay, so I'll tell you. So what happens is, let's say you want to kill it in two attacks. So that means in each attack you need to deal 5 damage. If it was 3, then in each attack you'll have to deal at least 3 damage. So H by X seal, this much damage per attack you need. And for one attack you already know how to calculate it. So you just change your damage to this and recalculate the ranges. Okay, and you can do this for, now you basically have the whole solution with you. So I'll just go over the code once again. So you're doing binary search on number of attacks for each attack, you can calculate the basically, let's say you have X attacks, you can calculate ranges L and R for each troop and then use partial sums, which was this technique I described, the putting +1 at L, putting -1 at R plus 1, and taking the prefix sum. You can use partial sums to calculate how many enemies you are killing at position P. And then if it is greater than equal to K, that means that so you know how binary search works, right? So you have a array. Uh, so let's say you have an array, and you know that you can kill it in X attacks. So you know can kill it in X plus 1, X plus 2, so on. So I have a left pointer here, a right pointer at the end here. And if I know that it is greater than K, that means I can still get a better answer if I update R. So I'll update R. If it's less, then I will update L, and so on, so on. And eventually you will get your correct answer based on the number of attacks. So yeah, I will let you guys implement it once. If you still aren't able to, then you can ask for the code. Okay, so any doubts so far? Because this was pretty complicated, I would say. Any doubts? Okay, so I'll move on to the next question. Um, okay, this is called ski resorts. I hope you have read it. So you have two arrays. One is the temperature, and oh, sorry, you have an array which has the temperature, and you have to select a contiguous segment which is at least k of size, and you need that segment to have a maximum temperature of q only, and you need to count how many such segments are possible. So okay, so this is pretty straightforward. The idea here is you use a single pointer I, you keep going, and let's say I have this array here, a1, a2, a3, a4. At any point, if you get a temperature which is greater than equal to q, that means you can't include this day here. So you update, you start from the next day, basically. So you update, so you set the current length to be 0. By current length, I mean the length of the subsegment here, of the subarray, basically. And how the main idea is, how do you count the segments in this case? So let's say I have I found some segment here which I have pointers L and R for, and it has a size whatever current size is. So you can notice one thing. Let's say I go to the next day, and this I can take this day here. So how many more subarrays can I create using this, which are of size k? This, this, like this. So it will turn out to be current minus k plus 1, where current is the current running length of the array. So I'll just show you the code for this because it's pretty simple. So you have a current length, you have the answer. If you're at any given point it is greater than q, you restart, and if current is greater than equal to k, you add current minus k plus 1 to your answer, and you keep doing this and you'll get your final answer. It's pretty simple. Any doubts in this one? Okay, I'll assume you guys have understood. Okay, now moving on to this question. I like I found this pretty interesting. Like it was very like unintuitive even for me. So what it says is you have an array and let's say I take 20. So I thought it was similar to like agar-ayo. So you take 20. Now anything which is greater than 20 you can eat and you can add that to your answer. So 20, if I remove 20, I start from 20 basically. I can eat 5, I can eat 1, I can eat 4, I can eat 2. So I can eat 4 people here. If I have start with 5, I can eat 4, 2 and 1, but I still can't eat 20 because 5 plus 4 plus 1 plus 2 is still 12, which is less than 20. Okay, so you get the idea. So, okay, one thing you can notice is obviously you need to sort the array. So, 20, I'll just copy 25, 1, 4, 2. Yeah, let's say I just sort the array 1, 2, 4, 5, 20. So if I'm at I can for sure eat everything which is behind me. So I can for sure eat I minus 1 people, right? And if I'm 20, I can eat everybody behind me. If I'm 5, I can eat everybody behind this. One observation is this. Another observation is, let's say I am at I can eat everyone here. So I calculate whatever sum this is. And if this sum is greater than this, I can eat this also. Okay. So what you do here is you make an answer array which is of size n. So what I can say is if my answer if for the ith element I can if I calculate the sum here, how do you calculate this? We obviously use prefix sums. Uh, so you calculate the prefix, which is the current health after you eat all the other things. So you have prefix of I. If this prefix of I is greater than the next element a of I plus 1, that means that this answer will be equal to answer of I plus 1, right? And I know for sure the last answer is n here. And for 5, I can calculate my answer. I'll just go do a dry run for you. So this the answer is 4. For 5, you know the prefix sum is 5 plus 4 plus 2 plus 1, which is 12, which is not greater than 20. That means the answer is what? 4. Sorry, 3 here. And for 4, what is the prefix sum? 4 plus 2 plus 1. So what will be the answer here? 4, 5, 6, 7, which is greater than 5. So that means I can still eat 3 elements. Because anyway, after I eat this, once I have eaten this, I am sure that however many I could have, basically I could guarantee that I can eat answer of I plus 1 monsters, because if you just started with I plus 1, you could have eaten these many. So I am for sure know that I can eat these many monsters. And so on and so on. I keep calculating this from n minus 1 to 1. And yeah, that's pretty much how you do this question. And this technique, if you guys don't know, this is called dynamic programming, because you're using the something which you have already calculated to calculate your current answer. That's about it. Any doubts? Okay, so I think Prakhar can take over.
Okay. हाँ, cool.